more there is to the universe than what meets the eye? We're not just talking about the twinkling stars or the majestic galaxies, but the enigmatic corners of space that hold secrets beyond our wildest imaginations. Let's take a moment to venture into the realm of brown dwarfs. These fascinating celestial bodies, too big to be planets yet too small to be stars, dwell in the twilight zone of the cosmos. Now meet W1935, an unusual member of this family. This brown dwarf has been leaving astronomers scratching their heads. Why, you ask? Well, it's cold. It doesn't have a host star, but it still emits infrared light from methane in its atmosphere, a feat that defies our conventional understanding. In the vast cosmic expanse, W1935 stands as a riddle waiting to be solved. Imagine the surprise of astronomers when they found W1935 emitting light from methane in its atmosphere. The James Webb Space Telescope, our window to the cosmos, was investigating a dozen cold brown dwarfs. These are celestial objects too big to be planets yet too small to be stars. Among them, W1935 stood out like a beacon in the night. This brown dwarf was not just another name in the catalog, it was different. It was special. It was emitting infrared light from methane in its atmosphere, a phenomenon that baffled the scientists. You see, methane emission requires energy, and W1935, being cold and isolated, had no apparent source of energy. Yet, there it was, glowing with methane emission. Even more intriguing was its similarity to W2220, another brown dwarf. They were almost identical twins in composition, but W1935 had this unique methane glow, while W2220 had none. It was like finding two puzzle pieces that fit perfectly, but one had a splash of unexpected color. As they probed deeper, astronomers discovered something even more startling about W1935. It had a temperature inversion in its atmosphere. That's where the temperature increases with altitude, a feature typically seen in planets with a nearby star to heat them up. But W1935 had no such star. It was like finding a snow-capped mountain in the middle of a desert. It simply did not add up. The mystery deepens as we delve further into the peculiarities of W1935. Are we looking at a cosmic anomaly, or is there a hidden logic to W1935's behavior? This question has been puzzling astronomers since the discovery of methane emission from this isolated brown dwarf. The emission of infrared light from methane in W1935's upper atmosphere is indeed a mystery, as the dwarf is cold and lacks a host star, leaving us without an obvious source of energy for this emission. A possible explanation lies in the concept of temperature inversion, a phenomenon where the temperature increases with altitude. This is typically seen in planets that have a nearby star heating their atmosphere. But wait, W1935 doesn't have a nearby star, so what's going on? To unravel this conundrum, our astronomers started looking closer to home, at our own solar system's gas giants, Jupiter and Saturn. These planets also exhibit temperature inversions, but their inversions are linked to aurorae. Could the same be happening with W1935? Without a stellar wind to contribute to the auroral process, our team had to think outside the box. They suggested that internal processes within the brown dwarf itself, or perhaps interactions with interstellar plasma or a nearby active moon, could be responsible for creating these aurorae. So, W1935, an isolated brown dwarf, might be the first auroral candidate outside our solar system with methane emission. This revelation opens up a whole new chapter in our understanding of the universe, proving once again that space is a realm of endless mysteries waiting to be unraveled. What does this discovery mean for our understanding of the universe? This question has been echoing in the minds of astronomers since the detection of W1935, a brown dwarf with the peculiar trait of methane emission. This cold, isolated celestial body, without a host star to fuel its energy, has left scientists puzzled, yet intrigued. The discovery of W1935 has broad implications for our understanding of brown dwarfs, these mysterious objects that straddle the line between planets and stars. It challenges our existing models, forcing us to consider new mechanisms for atmospheric phenomena. Could internal processes or interactions with interstellar plasma be at play, or perhaps a nearby active moon? These are the questions that now guide the scientific community. The James Webb Space Telescope will continue to probe W1935, studying its chemistry and potential auroral processes. This will not only deepen our understanding of this specific brown dwarf, but could also shed light on similar bodies in the cosmos. In the cosmic dance of the universe, W1935 is a step that has left astronomers intrigued, pushing the boundaries of our understanding and reminding us that there's always more to discover.